Welcome to calculus class. Today's lesson is called Integration by Partial Fraction Decomposition. Okay, so there are 10 steps that go into this process, and I think that after you've done them a couple of times, they're gonna just kind of occur naturally, but these would be what you'd put on a note card to just kind of make sure you remember the steps as you're studying for your AP exam. So if the degree of the numerator is greater than the degree of the denominator, you do long division first. So sometimes you get to skip this step. Number 2, factor the denominator. Number 3, and this is not going to make sense till we start doing it, but I will explain it in the problem and you'll get it. We're going to write our equation with a, b, c, ... to set up partial fractions. Step 4, we're going to multiply both sides by the denominator of the original function. Step 5, simplify both sides. Then step 6, on the right side, you're going to group like terms. So the example would be like your x squared terms, your x terms, your constant terms. Then step 7, on the right side, you're going to factor out your x squared, your x, kind of the constant as well. And then step 8, you're going to set up a system of equations and solve for a, b, c, etc. Step 9, you're going to rewrite your integral using partial fractions. And then the last step, step 10, is integrate each partial fraction individually. Now I am aware that these steps make no sense to you whatsoever, and that is okay, because I'm going to walk you through the steps as we do our problems. So these problems take up a lot of space. I would say that in today's lesson, I would not consider it to be a hard lesson, but the problems are lengthy and somewhat time consuming. So we won't do too many of them, but just enough to make sure you understand them and that you're able to do them on the AP exam. Also, when you take your AP exam, because it is a timed test, when I see one of these problems, I would probably skip it on the first run through, put a star by it or something, and say, okay, I do know how to do that problem, but I only want to mess with it if I have the time, because you might be able to get several problems done in the time that it takes to do one of these. But if you got through all the problems that you knew how to do quickly first, then this is probably one of the ones I would hit on the second run through, when you're like looking for problems that you know how to do, but they just take a little bit more time. So just kind of a test-taking strategy for you on this. So let's take a look at problem number 1. We are going to integrate 3x squared plus 1 over x cubed minus 9x dx. So the first step that we've had on our note card is if the degree of the numerator is greater than the degree of the denominator, which is not the case, so we get to skip step 1. Now, step 2 says factor the denominator. So I'm going to rewrite this integral with the denominator factored. There's a common factor of x in both of these terms, so I'll pull that out. That would leave behind x squared minus 9, which is a difference of squares. So I'm going to factor it x plus 3, x minus 3, dx. So step 2 is done. Now for step 3, it says to write an equation with a, b, and c to set up partial fractions. So we're going to step away from our integral for a minute. We'll return to it back at like step 9. But we're going to move away from it. We're going to say this integrand, and I'm writing an equation, so equations have a left and a right side of the equals, is equal to some mystery number a that we're going to solve for over x plus some mystery value b over x plus 3 plus some mystery number c over x minus 3. Now, this is kind of like if you have fractions with unlike denominators, you can get a common denominator and add them together to get one fraction as combined. So we're kind of doing the reverse of that. We're saying here it's already combined, but I want to break it up into 3 different fractions that would add up to this one if you were to seek a common denominator and put them together. So that's why it's called partial fraction decomposition. We're decomposing this fraction into 3 smaller fractions that would add together to give you this one. All right, so we did step 3. We wrote the equation with the a's, the b's, and the c's. And I mean, however many factors there are in the denominator, you'll need that many letters. So if there's only 2 factors, we'd only use a and b. If there was a 4th factor, we'd put a d. Each factor of the denominator gets its own letter of the alphabet. Okay, so step 4 is to multiply both sides of the equation by the denominator of the original function, which is this denominator on the left side. So I'm going to start just by copying it down. A lot of math is copying things over neatly. And now I'm going to multiply both sides of this equation by the denominator of the original integrand in factored form. Okay, so we did step 4. Step 5 is to simplify both sides. So on the left side, these will cancel out and I'll just be left with the numerator. On the right side, this is going to distribute to each of the 3 fractions. When it distributes, one of the 3 factors is going to cancel and the other 2 will be multiplied by the variable on top. So for example, on this first fraction, the x's are going to cancel and I'll have a times x plus 3 times x minus 3. On the middle fraction, I'm going to have b and the x plus 3's will cancel. So I'll have it times x and times x minus 3. And then on the last fraction, I'll have c with the x minus 3's canceling out times x plus 3. Okay? So we're not done simplifying yet. We have to actually multiply this stuff out to simplify it. So let's see. This multiplies out to give me x squared minus 9, because that's like the factored version of that difference of squares, plus b times x squared minus 3x plus c times x squared plus 3x. And now I'm going to distribute the a's, the b's, and the c's. So ax squared minus 9a plus bx squared minus 3 bx plus cx squared plus 3cx. All right, so I've pretty much simplified it like as far as I can, but now on step 6 it says on the right side group the like terms. So like my x squared terms need to go together. Oh, I got 3 of those. My linear terms with just the x's go together, and then my constant term, which I only have 1 of, will go at the end. So we're going to put them in descending powers of x. Ax squared plus bx squared plus cx squared. And then we'll put the linear terms, minus 3bx plus 3cx, and last goes the minus 9a. All right, now it says for step 7, on the right side, factor out the x squared, the x, the constant. So if I were to pull the x squared out of all 3 of these terms, I'd be left with a plus b plus c times x squared. And if I were to pull the x out of these 2 terms, I would have, and I want the sign to be inside the parentheses, so I'd have negative 3b plus 3c times x. And the last one, it's kind of weird. We're going to say plus the negative 9a, so I'm putting the sign in the parentheses, and then it's just a 1, a coefficient of 1 for your constant term. Okay, so we've got those factored out, which was step 7. So step 8 is to set up a system of equations and solve to find a, b, and c. So this is going to look kind of like work you did in Algebra 2. Basically, because of the properties of equality, if the left side of this equation is equal to the right side, then the x squared terms have to be equal, the x terms have to be equal, and the constant terms have to be equal. So if I take the coefficient of x squared on the left, which is 3, it has to equal the coefficient of x squared on the right, which is a plus b plus c. And if I take the coefficient of the linear term on the left, which is 0 because there is no linear term on the left, that has to equal the coefficient of the linear term x on the right. So that's going to equal negative 3b plus 3c. And then the last, the constant terms have to be equal. So the constant term is 3 on the left, and on the right, the constant term is negative 9a. So we have a system of 3 equations with 3 unknowns, a, b, and c. And we're going to solve like using methods such as elimination, substitution, to find a, b, and c. Obviously, the easiest one to find first is going to be the a because it is the only variable in this equation. So I'm just going to divide by negative 9 on both sides. And a is going to equal negative 1. What? Oh my, I've made a mistake a long time ago. See, I wish y'all were here with me so that I could have have you stop me when I do this. Did y'all notice that my numerator, 3x squared plus 1, turned into a 3x squared plus 3 for absolutely no reason at all? Okay. You know, I make these kinds of mistakes in class sometimes too. Usually I'll have one of you here to yell at me, not yell at me, but politely say, Mrs. Heiss, you messed that up. And I would stop the video and start it back over again, but I do not have enough time to do so. So we're just gonna change. Good thing I'm using pencil. Those 3x squareds plus 1. So this right side is fine, but it would equal the coefficient 1, not 3. Okay, 1 divided by negative 9 is negative 1/9. So that's the value for A. All right, if that's the value for A, that means I can substitute it into this equation for A. Now, in this equation, I can add 3b to both sides and say 3b is equal to 3c, and divide both sides by 3, so b equals c. And guess what? If b and c are the same thing, you don't really have to use different variables for those, do you? So in my equation over here, I could go plus b, because c and b are the same thing. Now I only have one variable in this equation, so I'm going to combine those two b's into a 2b, and then I'm going to add 1/9 to both sides. So let's think of 3 as 27/9, because 9 times 3 is 27. And then we're going to add a positive 1/9 over here. So if I add that 1/9 to both sides, I'm going to get 28/9 equals 2b. And then I'm going to divide by 2 or multiply times 1/2 on both sides. If I do times 1/2, 28 is going to get divided by 2, which will give me 14/9 equals b. And since b and c are the same thing, 14/9 is also going to equal c. All right, I believe we've got it all corrected now. I'm going to put this little solving the system thing in a little happy cloud to offset it. Offset that solving the system work that we learned in Algebra 2. And now I have solved my system, so I've completed step 8, and now I'm going to go to step 9, which is to rewrite my integral using partial fractions. So my integral was originally, 3x squared plus 1 over x times x plus 3 times x minus 3 dx. So now I'm going to rewrite this as the integral of, okay, now I need to jump back up here and look. It's a over x. So what is my a? Negative 1/9 on top of x. Plus, next fraction was b over x plus 3. So b is 14/9 over x plus 3. And last, it was c over x minus 3. C is also 14/9 over x minus 3 dx. Now, how did this help me? Well, the last step is to integrate each partial fraction individually. So I want to think of this as the integral of this first fraction, which I could pull that negative 1/9 out in front and just make it be 1 over x dx, plus pull the 14/9 out in front times the integral of 1 over x plus 3 dx, plus pull that 14/9 in front of this integral, the integral of 1 over x minus 3 dx. Okay, so the integral of 1 over x is a note card. So that is going to give us negative 1/9 times the natural log of the absolute value of x, plus the integral of x plus 3 is a u substitution, but when you take the derivative of the u, you just get 1. So du is equal to dx. So that means you don't have to multiply by anything. So you can just say this is 14/9 times the natural log of the absolute value of x plus 3 plus 14/9, same thing here. It's a u substitution of the 1 over x note card, but since the derivative of x minus 3 is just 1, you don't have to multiply by anything, so you can just say natural log of the absolute value of x minus 3. And then we put our plus c at the end. So this is our answer. And yes, this did take a whole page of work, and yes, it took quite a bit of time, but it's a pretty manageable process once you get a little bit of practice under your belt. So that's what we will do. Let's look at problem number 2 next. For number 2, we're going to do the integral of x to the 5th minus 4x cubed plus 1 over x cubed minus 4x dx. So, the first step of our process was to look at the degree of the numerator and the denominator. The degree of the numerator is 5, the degree of the denominator is 3. So the degree of the numerator is greater than the degree of the denominator. That means on this problem we don't get to skip step 1. We have to do long division first, which means we're going to take the numerator, which is x to the 5th minus 4x cubed plus 1. And we're going to divide it by the denominator, x cubed minus 4x. And so we're going to do this using lots of algebra 2 today. What number would you multiply an x cubed by to give you an x to the 5th? We're just looking at the first term here and the first term here. That would be x squared, right? So I'm going to put an x squared on top. I'm kind of putting it between these two because of lining up powers. Now I'm going to take x squared and multiply it by these two terms. So x to the 5th, x squared times x cubed is x to the 5th. X squared times negative 4x is negative 4x cubed. And now I'm going to subtract. And if you do long division a little bit differently than me, like changing the sign on each term or anything like that, do it the way you learned it. You're going to be better at it that way and make less mistakes. So x to the 5th minus x to the 5th is 0. Negative 4x cubed minus negative 4x cubed is 0. And then we bring down our 1. Now, this is our remainder because this is now of lesser degree than what we're dividing by. So the way we handle the remainder is we go plus the remainder, which is 1, over the denominator, what we were dividing by, x cubed minus 4x. Okay? So there's your little algebra 2 review. Now, we're going to rewrite our integral because this divided by this gives us this. These are equivalent. So we're going to rewrite our integral as the integral of x squared plus 1 over x cubed minus 4x dx. And now we can separate this because that first one is going to be really easy to integrate. We'll say the integral of x squared dx plus the integral of 1 over x cubed minus 4x dx. So this integral is one that we have to do using partial fraction decomposition. So this one we'll be able to do just fine, but this one we've got to step into the little partial fraction decomposition steps. So I'm going to factor the denominator and write out my equation with the a, the b, and the c. So it's going to be 1 over let's see, the x comes out. That's going to leave me with x squared minus 4. And so I can break that up, because that's a difference of squares, into x plus 2 times x minus 2. And this will equal a over the first factor plus b over my next factor plus c over the final, factor. Okay, so I've got my equation. Now I'm going to multiply both sides by the denominator of the original fraction. So left side, right side, x plus 2, x minus 2, x plus 2, x minus 2. Those cancel out and I'm left with 1. And here I'm going to have a, the x's will cancel, and I'll have x plus 2, x minus 2, plus b, x plus 2's divide out, so I'll have times x minus 2, and then c, x minus 2's cancel out, so I'll have times x plus 2. Now I have to simplify. So I'm going to multiply my x plus 2 times my x minus 2, which gives me x squared minus 4, plus b times x squared minus 2x, plus c times x squared plus 2x. And now I'm going to distribute the a, the b, and the c. Ax squared minus 4a plus bx squared minus 2bx plus cx squared plus 2cx. All right, now I've simplified it as much as I can. On the right side, I'm going to group my like terms. So my x squareds will go first, my linear terms will go second, and my constant term will go last. So I have 1 equals ax squared plus bx squared plus cx squared minus 2bx plus 2cx, and then minus 4a. And now I'm going to do step 7. Factor out the x squared, the x, and the constant. So a plus b plus c times x squared plus negative 2b plus 2c times x plus negative 4a times 1. And now I'm going to set up my system of 3 equations with 3 unknowns. So notice on my left side, I only have a constant term. There is no quadratic term and no linear term, which means the coefficients of those are zeros. So I'm going to write 0 equals a plus b plus c. 0 equals negative 2b plus 2c. And 1 is the constant term, so 1 is equal to negative 4a. Now I'm going to solve this system of 3 unknowns using my Algebra 2 skills like substitution and elimination. So on this one, I'm going to divide by negative 4 on both sides, so I'll have negative 1/4 equals a. I can go ahead and sub that in for this a now that I know what it is. Here I'm going to add the 2b to both sides. 2b equals 2c. Divide by 2 on both sides. b equals c. And that means over here I can say plus b, because since b and c are the same, I can just use the same variable for both of them. So that means positive 1/4 will equal 2b. And if I multiply by a half on both sides, 1/8 will equal b, and 1/8 will also equal c because they are the same. All right, So I'm going to put this substitution, solving the system work in a happy little cloud. And I'm going to return to my integration problem. Remember, the original integration problem looked like this. So I'm going to rewrite it now with the second part being set up with the 3 partial fractions, now that I know what A, B, and C are. So that's going to be the integral of x squared dx plus the integral of A over x. A is -1/4 on top of x dx, plus the integral of b over x plus 2. b is 1/8 over x plus 2. And then last, c over x minus 2. c is 1/8 over x minus 2 dx. All right. So I'm going to pull those constants out in front of the integral symbols before I start integrating. So I'm going to have the integral of x squared dx minus 1/4 of the integral of 1 over x dx plus 1/8 of the integral of 1 over x plus 2 dx plus 1/8 of the integral of 1 over x minus 2 dx. So what is the integral of x squared dx? Well, do power rule backwards, 1/3 x cubed. Here, what's the integral of 1 over x? It's going to be minus 1/4 natural log of the absolute value of x. Then we're going to have plus 1/8 times the integral of 1 over x plus 2 is a u substitution, where it's like we're integrating 1 over x, but x plus 2 is the u. But the derivative of x plus 2 is 1, so du and dx are the same, so you don't have to multiply by anything. So it's just going to be the natural log of the absolute value of x plus 2. And then plus 1/8 natural log absolute value of x minus 2 plus c. That's the answer. It's a lot of work. I know it is. But it's not hard work. It's a lot of algebra. Some of y'all love algebra. I bet you're enjoying this. Okay. Some of y'all are like, just give me some steps to follow and I'm good to go. I get it. So number 3. Integral of 5x minus 5 over 3x squared minus 8x minus 3 dx. All right. Let's check those degrees. The degree of the numerator is 1. The degree of the denominator is 2. So we do not have the situation where we have the larger degree on top. So we can skip step 1. No long division required here. So we're just going to go to the next step, which is factoring the denominator and writing out our equation with the a, the b, and the c. So it's going to be 5x minus 5 over, let's see, can we factor a quadratic? 3x, x, we need a 3 and a 1, where when we multiply the subtract to make -8, let's see, so this would give me a -9, and this would give me a +1. So that would give me a -8 for my middle term. Okay, so this should equal a over the first factor, 3x plus 1, plus b over the second factor, x minus 3. Now I'm going to multiply both sides by the denominator of the left side. X plus 1 times x minus 3, 3x plus 1 times x minus 3. So 5x minus 5 will equal a times, that first factor cancels, so it'll just be times x minus 3 plus b times that second factor cancels, so it'll just be 3x plus 1. Now I'm going to distribute a and b, ax minus 3a plus 3bx plus b. And now I'm going to group my like terms. I don't have any quadratic terms this time, but I have two linear terms, so I'll put them first. Ax plus 3bx, and then my constant terms, negative 3a plus b, will go next. Now I'm going to factor the x and kind of factor the 1 out. So this will be a plus 3b in the parentheses times an x plus negative 3a plus b times 1. Now I'm ready to set up my system of equations. This time I'm only going to have two equations with two unknowns, a and b. So we have a linear term on both sides. The coefficient of the linear term on the left is 5, and the coefficient of the linear term on the right is a plus 3b. So those have to be equal. The constant term on the left is negative 5, and the constant term on the right is negative 3a plus b. So those have to be equal. Now, we need to solve for one of the variables, whichever one looks easy to isolate. I'd say the a looks pretty easy to isolate here. So what if I just subtract 3b on both sides and say 5 minus 3b equals a? Now I'm going to take that and drop it in place of the a over here, doing a substitution. So negative 5 equals negative 3 times 5 minus 3b plus b. And now I'm going to solve for b. So I'm going to distribute the negative 3. So negative 15 plus 9b, and then we have the plus b on the end. We'll combine those like terms, and we could go ahead and add the 15 to both sides. So 15 minus 5 will leave me with 10 on the right, and I'll have 10b over here. 10 on the left, and then 10b over here on the right. Divide by 10 on both sides, I get 1 equals b. That's nice. So I'll go ahead and take that 1 and sub it in for the b over here on the left to get a. So 5 minus 3 times 1 equals a. That's just 5 minus 3, so 2 equals a. All right, so I have solved the system of equations for my missing a and b values. And now I'm going to go back to my integral problem. So I was originally taking the integral of 5x minus 5 over, 3x plus 1 times times x minus 3. 3x plus 1 times x minus 3 dx. And so now I'm going to rewrite this as the integral of a over 3x plus 1. A is 2 over 3x plus 1 dx, plus the integral of b over x minus 3. So b is 1 over x minus 3 dx. Okay, so I'm going to pull the constants out in front of the integral symbols. So 2 times the integral of 1 over 3x plus 1 dx. Oh, and there is no coefficient over here. 1, but pull out a 1, that doesn't do much, does it? So now I'm ready to integrate. Now, can I just write 2 times the natural log of the absolute value of 3x plus 1? No, I can't, because the derivative of 3x plus 1 is 3. So this is one where we actually have to consider the u substitution work. U is equal to 3x plus 1. And you can do this in your head, in your brain if you want. Probably be a good idea. So the derivative of u with respect to the variable x is 3. du equals 3 times dx, so 1/3 du is equal to dx. So I'm going to come over here and rewrite this first integral as 2 times the integral of 1 over u, because 3x plus 1 is coming out, u is going in its place, dx is coming out, and 1/3 du is going in its place. Now this one I can just do like we did on the last problem. You don't have to do u substitution necessarily if the derivative of the inside function x minus 3 is just equal to 1. So I'm going to pull the 1/3 out in front. So this is going to be 2/3 times the integral of 1 over u du plus the integral of 1 over x minus 3 dx. And what does that give me? Well, 2/3 natural log absolute value of u, but I'm going to come back and put the 3x plus 1 in the absolute value bars. And then I'm going to go plus the natural log of the absolute value of x minus 3 plus c. And that is the answer. All right. We just have one more. And if you were with me in class today, I would have you pause the video and try this one in groups with each other. But since we are not together, you should pause the video and try it on your own. And then you can push play to see how you did. Okay? So this is the problem. I want you to give it a try and then push play to check your work. Hopefully you have done so by now. First thing I'm going to do is rewrite this integral as 1 over the factored version dx. So it's x and x, 7 and 1. I need my middle term to be negative, so negative 7x and positive 1 will do that for me. And now I'm going to write the integrand equal to a over x minus 7 plus b over x plus 1. And now I'm going to multiply both sides by the denominator of the left side. So let's copy it first. So we've got x minus 7, x plus 1, x minus 7, x plus 1. So 1 equals a times x plus 1 plus b times x minus 7. Distribute ax plus a plus bx minus 7b. I'm going to group the like terms. Ax plus bx plus a minus 7b. I'm going to factor a plus b times x plus a minus 7b times 1. And I'm going to set up my system. I have no linear term on the left, so 0 is going to equal a plus b. And 1 is my constant term on the left, so that's going to equal the constant term on the right, a minus 7b. Now, you could do this one pretty easily using elimination, or you can do substitution. Let's do elimination. If I multiply this equation times a negative 1, I get 0 equals negative a minus b. And the a's will add out to 0. 1 equals negative 8b. So, is that right? Okay. So if I divide by the negative 8, negative 1/8 equals b. And now I can put that in over here. 0 equals a minus 1/8. Add the 1/8 to both sides. 1/8 equals A, negative 1/8 equals B. So now I'm going to rewrite my integral. The integral of 1 over x minus 7 times x plus 1 equals A, which is 1/8, over x minus 7, the integral of 1/8 over x minus 7 dx, plus the integral of b, negative 1/8 over x plus 1 dx. I'm going to pull the 1/8 and negative 1/8 out in front of my integral symbols. And then I'm going to integrate 1/8 natural log absolute value x minus 7, because the derivative of that inside function x minus 7 is 1, minus 1/8 of the natural log of the absolute value of x plus 1 plus c. All right, if you got this answer, this is good, this is correct, but I'm going to tell you on a multiple choice problem, and yes, they do put these on the multiple choice section sometimes. I know that's a lot of work for a multiple choice question, but they do it. Because these two have the same coefficient, you can actually put these together by using log properties. Remember when you have one log minus another log, they have the same base? You can put them together. I'm talking about this property like right here. The log of A minus the log of B equals the log of A over B. You remember that from Algebra 2? Because these have the same coefficient and the same base, you can say this is 1/8 natural log absolute value of x minus 7 over x plus 1, and then plus c. So this is the best answer, most simplified answer. This answer would have been just fine if it was a free response question, but if it's multiple choice, they're probably going to go ahead and do that final simplification of this. But of course, if you got it here and you were looking at the answers and none of them said that, but you saw this, you could probably make the connection that those were the same thing because of what you know about your log properties. Okay. I did not give you too many of these to do for homework, just enough for you to practice it so that you're going to know it, because you're going to need to know it. And we're going to use this again this year as well. So, in addition to on the AP exam. So practice it, get good at it, don't rush through it, and email me or let me know if you need help, ask for help, and I'm here for you. I hope that you enjoyed this lesson, and I hope that you have an absolutely wonderful day. Bye for now.